Hi, and welcome back to my channel, Math Caffeine. This is part 1 of 5 in a series about reasoning and proof in geometry. Let's dive right in. Important terms. A conditional statement is a logical statement that has two parts, a hypothesis P and a conclusion Q. It is written in an if-then form, where the if contains the hypothesis and then contains the conclusion. For example, look at the statement. If an animal is a bird, then it has feathers. The hypothesis is that the animal is a bird, and conclusion is that it has feathers. When you negate a conditional statement, it is the opposite of the original statement. For example, the negation of the statement "the ball is red" becomes "the ball is not red." There are several different alterations you can do to a conditional statement. The first is to write its converse. To do this, you just switch the hypothesis and the conclusion. For example, if the conditional statement is, "If you play basketball, then you are an athlete," then its converse is, "If you are an athlete, then you play basketball." Another related conditional is an inverse, where you negate both the hypothesis and the conclusion of the conditional statement. Using the example we have already, the inverse would be, "If you don't play basketball, then you are not an athlete." Finally, a contrapositive takes the converse of a conditional statement and negates the hypothesis and the conclusion. Using the converse we created, the contrapositive would be, "If you are not an athlete, then you do not play basketball." Equivalent statements occur when a conditional statement and its contrapositive are both true or both false, or when the converse and inverse of a conditional statement are both true or both false. The last important term for this section is called a biconditional statement. When a conditional statement and its converse are both true, you can write them as a single biconditional statement, which contains the phrase "if and only if." Let's use an example. If two lines form a right angle, then they are perpendicular. This is true. Now let's look at its converse. If two lines are perpendicular lines, then they form a right angle. This is also true. So we can write a biconditional statement as follows. Two lines form a right angle if and only if they are perpendicular lines. This will conclude part 1 of 5 of the Reasoning Proofs series. If you have any comments, questions, or concerns, feel free to email me at mathcaffeine@gmail.com. Happy studying!